Assalamualaikum. My name is Nur Al-Aina Meti Muhammad Sufyan, metric number 1711152. I'm going to present the objective of this study. First, the main objective is to find out the relationship between financial development and economic growth in 80 countries all over the world in the year of 2018. For summary statistics, the data on mean and standard deviation were obtained from the e-views, and the data from the minimum and maximum were obtained from Excel.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Econ. I will explain about the data used in our study. The dependent variable in our study is GDP. It is measured using the GDP growth of each country in 2018. There are 7 independent variables in our study. The first one is FIN. It is measured using the domestic credit provided by financial sector as percentage of GDP in 2018. The second one is money. It is measured using the broad money growth in 2018. The third one is brief. It is measured using the domestic credit to private sector as percentage of GDP in 2018. The next one is SCORF. It is measured using the general government final consumption expenditure as percentage of GDP in 2018. The next one is saving. It is measured using the gross savings as percentage of GDP in 2018. The next one is GNI. It is measured using the gross national income per capita based on purchasing power parity in 2018 in current US dollar. The last one is debt. It is measured using the binary indicator of developed country.
Assalamualaikum warahmatullahi wabarakatuh. I am Nuriza Shaharistan. For our model, we construct a linear form model as shown, and our prior expectation is that all coefficients beta 1, beta 2, beta 3, beta 4, beta 5, beta 6, and beta 7 are expected to be positive, and we expect that all explanatory variables will affect GDP growth positively. After constructing the multiple regression equation model, we then run our multiple regression model in e-views to get the initial test result, which leads us with beta 1 equals to 0.013, beta 2 equals to 0.117, beta 3 equals to negative 0.008, beta 4 equals to negative 0.114, beta 5 equals to 0.037, beta 6 equals to negative 2.63 times 10 to the power of negative 9, and beta 7 equals to negative 1.218.
Equation. For any specification error that may exist in our model, specification error could happen in our regression equation if we exclude important variables, include unimportant variables, as well as using incorrect functional form. Therefore, we conduct a Ramsey reset test to check if there is any specification error in our model or not. After we conduct a Ramsey reset test, we found that F statistic value is 0.870907. Therefore, we conduct a hypothesis testing. Since the F statistic value is smaller than its critical value, H0 is not rejected. Therefore, there is no specification error in this model.
To check on multicollinearity problems, we conducted 7 auxiliary regressions as we have 7 explanatory variables. For each auxiliary regression, an explanatory variable will act as a dependent variable to be regressed with the other explanatory variables. The cutoff value of R squared to indicate the multicollinearity problem would be R squared greater than 0.8. We found 2 auxiliary coefficient result that its R squared is greater than 0.8. This shows that severe multicollinearity exists in our model. As a remedy to this problem, we decide to do nothing, as some of our variables are still significant and consistent with our expectations. And if we were to drop a variable, the changes on the t-value is not that much, and it might also affect our specification error.
In the serial correlation, we have 2 types of it, which is pure and impure serial correlation. But in our study, we use pure correlation because we have no specification error. The method that we will be using to check for serial correlation are 2, which is Durbin-Watson d-test and Busch-Godfrey LM test. So first, we go for Durbin-Watson d-test. In this test, we can see that the Durbin-Watson statistic is 2.126. With n, k, and alpha, we're going to get the du and dl. Du is for upper critical and dl is for lower critical, which is du is 1.831 and DL is 1.425. So, the hypothesis testing in this test is Durbin-Watson value is larger than DL, which is 2.126 or larger than 1.425. So, our decision is going to accept H null. Therefore, there will be no first-order serial correlation. Next, we go for Bruch-Godfrey LM test. The equation of the error term are as shown in the slides. With alpha of 0.05, degree of freedom for denominator of 70, and degree of freedom for numerator is 2, which is obtained from the e-views. F value is 3.13. The calculated F statistic of 0.183290, we find out that F statistic is lower than our critical value, which is 0.183290 are lower than 3.13. Our decision is do not reject H null.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Shazwani binti Ishaq. So in our model, we use white test to test for heteroscedasticity problem. For white test, we use e-views, and the output that we get, we run the hypothesis testing. As a result, we get the test statistic chi-square is 10.961, lower than the critical value 14.067. So we accept the null hypothesis, and there are no heteroscedastic problem in our model. It means that the error terms has a constant variance. Next, for final model, we conduct t-tests for each explanatory variables to test for individual significance. From the hypothesis testing, the result we get, money, government, saving, and development has a significant, and the other variable, fin, private, and GNI are not significant. For overall significance, we conduct F test on all explanatory variables. So the result we get, F value is 7.01, is greater than the critical value 2.13. So we reject H null, and it means that our model has an overall significance.
After we have carried out the test, we found that there is no specification error in the Ramsey reset test. However, there is problem of multicollinearity as the value of R squared of priv and fin are greater than 0.8. As a remedy to this problem, we decide to do nothing because some of the variables are consistent with the expectations. Meanwhile, there is no problem of serial correlation in both tests, and our regression equation is proven to be homoscedastic. When testing for individual significance, only money, gov, and dev are proven to significantly affect the dependent variable. The rest will not significant. Moreover, when testing for overall significance, we can conclude that the independent variables are jointly significant. Further improvements can be made in our analysis by including a larger sample size. We are not able to increase the sample size as the data provided by the World Bank is very limited to match all the variables included in the model in 2018.